Yes. Hi, my name is Cory Levinson. I'm a sort of hybrid software developer, data analyst, product manager, originally with a background kind of in the data analytics and data science space. Over the years, been working doing kind of product management for data infrastructure teams, and generally in that field, I'm working amongst things like the Apache Hadoop ecosystem. So if people are familiar with those kinds of tools and like Spark and MapReduce, and that's generally where I've operated for work and in the professional capacity. But this talk today is going to be about a project that I worked on earlier this year in Moscow, where I was at the Strelka Institute during their New Normal research program. And within the context of that program, worked on a group project that was sort of set on the time horizon of looking at Russian cities in the year 2050. So kind of a futurist, speculative urban design program. And this project Phi kind of came from that. So there's my little intro spiel over an ominous sort of Phi logo. We actually found out midway through the project that the proper Russian pronunciation of this Cyrillic letter is F, which is a little less exciting than we had anticipated. But so Phi, just kind of as a quick overview, is a project similar to the guy who gave the lightning talk earlier, is about peer-to-peer energy, and specifically kind of operating in the space of like blockchain and a shift towards renewables that can look kind of towards community microgrids. So as a first thing, we're going to kind of look at like the case for peer-to-peer energy. So historically, at least within the Russian context where we were doing most of our research, there's a big legacy of centralized energy systems. If you even go back to Lenin, he had this quote in the early days of communism being Soviet power plus the electrification of the entire country. And now we're kind of, in Russia at least, dealing with this infrastructure that in many ways is kind of no surprise. People are aware that it's quite brittle, it's kind of falling apart, and especially in Russia, similar to in Canada, here in North America, you've got a lot of landmass with really, really not dense populated areas in the north, and most of the population is actually on the sort of southern area of the country. And as you go further north, it's a lot less likely that people are going to be connected to the grid. And in Russia, as well as in our research we were seeing in Canada as well, there was this common thing of people getting sort of diesel fuel shipments to these remote regions. And so we also kind of see peer-to-peer energy as kind of enabling or being another sort of enabler for this transition away from fossil fuels in light of kind of the US having these really strange current relationships with the Paris Climate Agreement, which should be something that is pretty easy to get behind. It was clear within our research that we wanted to try and look at different types of incentive structures for challenging and combating climate change, ones that maybe could be more bottom-up, that didn't depend on large nation states to kind of like full-on lead that charge, but ones that could be more sort of community-driven. And sort of a last kind of case that I'll make is, you know, we're here today at Radical Networks. We're talking a lot about autonomous networks, community networks, but one of the things that often gets left out of those discussions is actually autonomous energy. So what does it mean for communities, you know, especially if we're looking at like extreme scenarios around disaster relief, like how can a community be fully self-sufficient in a situation like that, also including the energy and the way that they're getting electricity sort of to start with. And so with this kind of as a context for why we were looking to peer-to-peer energy as a use case, we kind of switched gears to look at sort of technology today and what are the aspects of the current kind of broader sort of tech landscape that we wanted to pull into the work that we were doing. And so one of the first threads that I'm going to touch on and that maybe you'll see throughout the project is this idea of data visualization. So it should be no surprise that data viz techniques kind of allow us to work with large-scale data sets to manage sophisticated systems. Power grid energy management is typically a very sophisticated system that as consumers, people aren't interacting with at all. So there's going to be a big aspect to the work that we did that tried to look at this. A second one is this idea of AI-enhanced interfaces. And here, the way we're thinking about this is that these AI interfaces being that boundary point that sort of sits between what decisions the machines are making, what decisions the humans are making. And at least the way I think about it, this isn't something that that we decide, oh, we're going to make an AI interface. This is something that always exists when you're dealing with computing systems. There's always some decisions that's being automated, that's being sort of offloaded to the machine. And so it really is just a question of like where on that continuum you want to draw your boundary, and you want to let that interface sit. And so this was another way that we were kind of thinking about the work that we did for Phi. And the last is this idea of blockchain-based systems of value. So with blockchains, the way at least we kind of saw it, you're really able to, for the first time, design kind of new incentive structures, typically in the form of tokens. So from a finance industry perspective, people often see this as like designing monetary policy that's not sort of mandated by the state. But then at the same time, from like a game theoretical, or in our case, a weird sort of SimCity-like perspective, these are really just the rules of play. In a kind of nod to, I think it was Nicholas's talk from last night on marketplaces within virtual games. There's definitely a lot of similarities to how his research was developing to some of the things that we were thinking about. And so with these kinds of developments in mind, we were sort of looking towards what was future for, or what was possible for the future of kind of renewable energy systems. And with that came to our project Phi, your interface to peer-to-peer energy. And so Phi is a software platform for reimagining our relationship to infrastructure, or to energy infrastructure specifically. That's kind of like the tagline that we found ourselves settling on. And it has two main components. The first of which is an intuitive interface that allows users to simulate and create clean energy networks. And the second is this kind of blockchain-based token system that enables people to relate to energy infrastructure and then also each other in new ways. So as a first thing, I'm going to kind of walk through these token systems. Then we'll talk about also the different phases that the project kind of enables users to interact with the system. And then we'll do a short demo as well. So tokens in our system allow us to digitize physical assets and design new kind of incentives for renewable energy. Electricity within this context isn't sold in a traditional sense, but it's rather traded for tokens that can represent a number of things, like the amount of energy you have stored in batteries, the reputation that a certain peer has, where a peer is kind of like a household or a school or so on, and also the amount of energy that's not used. And so to walk through each of these individually, the first is called joules. Joules, literally speaking, is that exact tokenization of energy. This should be no surprise to people who are kind of familiar with this space. There are a number of companies that are a bit more grounded in the real world today, trying to take on projects in the blockchain and energy space. And the very first thing that they're doing is this actual tokenization of the energy that's generated by either solar panels or coming in through a utility, and then the actual transfer of that energy throughout a network between peers. The second is called seed rating. This is a reputation score based on the importance of a peer to energy trading. Negawatts represents the amount of joules that a peer does not use. So you could imagine in a community setting, you'll have a bunch of people who maybe within a community decide on a local cap for how much people should be consuming. Maybe that's the same for all of the nodes in a network. Maybe a school is allowed to consume more on a weekly basis than a small household. But regardless, you have these kind of local caps, and whatever you don't consume relative to your expected kind of consumption or desired consumption, you're rewarded in the form of these negawatt tokens. And then those negawatt tokens could at a later point in time be kind of traded back for joules in the future. And then the final token is called Phi coin, which is your sort of more generic, more standard kind of cryptocurrency token generation event, ICO coin, which would really serve the purpose of kind of seeding investment into the platform initially at either kind of a larger global scale or at a small community scale. And then that money would then be used basically for the actual investment and development of the renewable energy networks that, as we'll see shortly, the simulation kind of proposes. And so these tokens kind of embody our system through the interface that we designed. Although they're a bit hidden, when we go through the demo, you won't be seeing like the tokens flying around, but the idea is that we wanted to present users with the stuff that made sense to them and that we wanted to kind of expose at that layer. And so the two components for the interface that we sort of settled on was first a grid-based map with peers. So this is a typical kind of like network layout. And so all of these would be consumers. And then generators, the yellow squares that you're seeing would be solar panels, but also like in some regions, wind makes more sense, wind energy. So these blue triangles are representing wind turbines. and then cables overlaying them, all overlaying this kind of geographical layout. And then on top of it, there's a dialogue window with a chatbot interface to kind of inform the user and help walk people through this process of like building a network. And up on the top, you're seeing a little status bar. So that's kind of showing you your budget for the network that you're trying to spin up, but also you get some understanding of coverage and health, different metrics that tell you kind of like how much of the community you're able to cover. And in comparison, I know this looks like a lot that's going on right here, but these are the kind of systems that people are used to dealing with when they're working with this kind of technology. So our hope was that reducing things to these two kind of core elements of map and chatbot would be a bit of an improvement. And so to understand the kinds of things that are capable within Phi, we broke the project down into 4 phases. These phases allow users to first of all, to simulate peer-to-peer energy networks, to compare and contrast different configurations of network topology and also economic design. Secondly, to kind of invest in energy infrastructure. This includes collaboration and voting tools to help communities select and fund different network designs. Also to actually create the clean energy infrastructures in real communities, and then as part of this would also be a sort of aspect of data collection that would then feed data from real like solar panels and smart meters and whatnot back into other simulations that different members of a community would be running. And as, I should say, as like simulate, invest, and create sort of create this virtuous cycle, the idea and the hope is that communities are then finally kind of reorganizing to facilitate further development and renewals, both at a community and kind of at a larger global level. And so we're going to start, I'm going to switch out of the presentation and do a quick demo. Sorry, I have to switch to mirror displays. Can you see that? Is that font size okay? Cool. So if we load this from scratch, you kind of see a very blank sort of grid layout at the beginning, and Phi kind of greets you. Hello, I'm Phi, your interface to peer-to-peer energy. I can help you design, simulate, and manage renewable energy resources and biosensors. So maybe the first thing we'll do is we'll start off with a question. Something like, hi, Phi. So how does the simulation work? Welcome to Phi. What would you like to know? Okay, maybe we'll ask something a little more specific. How do projects get launched in the real world? And Phi responds, at the moment, I can only simulate networks based on real data, but in the future, it will be possible to involve multiple users, decision-making on investment, voting, and management of real-world energy networks. So, okay, you have a bit of an idea of how things go here. And if we click Get Started, we're then prompted to load. Right now, the only location where we did our development in is in Ust-Karsk. So welcome to Ust-Karsk, a remote off-grid community located in the southeast Russian region with great potential for solar power. You've received a 10,000 investment in Phi-Coin to further develop the renewable energy networks in Ust-Karsk. And on the map to the right, you can see the local Phi network in Ust-Karsk. Phi networks are made up, and then Phi's kind of walking us through the fact that we can see piers, solar panels, wind turbines, and cables. So as you move over here, you can kind of zoom into the map and interact with these different elements. The blue sort of outline circles that you're seeing is the consumption profile, so how much a given pier is trying to consume or has as their desired consumption for a given day. And then Phi also reminds us that we can always ask for more questions. So if we click this Buy Generators button, you can see all of these gray nodes light up, and this is where if we wanted to, we can just sort of in a nice like click interface, add more generators to the network, and Phi's telling us how much they're costing. You can see our budget kind of decreases accordingly. And now if we install some cables, you can actually link these up together and connect them to some of the piers. And now once you've kind of gone through this process a bit, You can proceed through a day cycle. So if we click this next day button, what you're seeing here is you're seeing a kind of weather simulation and energy sort of propagate to the generators and then to the peers that they're connected to. And then all of the peers, these circles around them are kind of filling up in proportion with how much of the energy that they'd like to receive are they actually getting from the fee network. And those are also reflected on more of a global sense in these two sort of circular status bars that you see in the status window on the upper left. So health is kind of showing us what percentage of the energy that's desired from this community are they actually able to get from the fee network. And coverage, which is at 8% right now. As you can see, there's maybe like 10, 15 different nodes here. But if we were to add more peers, you can see all of these gray nodes are all of the rest of the nodes in Uskarsk. So eventually, you would kind of go through this simulation by adding more peers, adding more generators, connecting them with cables, and trying to get maximum both coverage and health for the network. So that's a quick overview of the kind of stuff that's possible in the simulation that we have live. That's all available on via our website, which you can get directly here to fee.zone. Now I want to go back. Where's my thing? There we go. Okay, cool. And so now you can kind of see a sense of what's sort of possible today, but obviously like in the future, and as I kind of described with the scope of the project, like we're looking forward to at some point like expanding this to be possible in more of a multiplayer mode, which allows kind of the second phase around investment to start to come into play. So as you can see, in this mode, you'd be able to kind of chat and work together with your neighbors, suppliers, mechanics, and so on in a local community to simulate your ideal city in terms of your energy configuration. And the simulations you design would be submitted to the network so people can vote on it. And in this way, everyone kind of plays their part in how to spend the communal funds through this collective investment process. And the idea here is that instead of one mastermind kind of deciding what's best for the city, we would want these decisions to be made from the bottom up. And after your community decides on an investment proposal, this sort of third create phase would begin. And so here you can start setting up your infrastructure, putting your simulation into the real world. And in this create phase, be it solar panels, wind turbines, or cables would be installed with smart metering technology that could plug into the fee platform. And once that happens, kind of trading would automatically begin, and also the data that your infrastructure produces can be shared with the network. And another point here is that the kind of data that's collected and shared within the network would result in you being rewarded in fee coin as well, because you're helping kind of other people make better simulations. And so you can see, as I mentioned before, there's kind of this constant loop between simulate, invest, and create. And this will help the fee network grow more precise, efficient, and robust is the idea. And with all of that, this last idea of kind of reorganizing comes into play again. And so by implementing fees network designs in the real world, communities, some aspects of energy, power distribution, social relationships, and economic models can get reorganized. And there's a few different ways that we kind of think about this. The first is just rethinking the relationship between computation and energy. So computational networks, as we see it, sort of index the consumption of electrical energy already, from global data centers that consume more electricity than large countries, to the proof of work consensus mechanisms that are already in place in some of the cryptocurrencies like Bitcoin and Ethereum today. And so with fee, we were really trying to kind of take a more direct look at that relationship and find ways to sort of find like interesting fissures or cracks between that. A second point for us around this reorganization principle was that value is active and created through trust. So rather than having value be something that's specifically like a metric that is tradable explicitly as a token, like a single thing that kind of like has this discrete value, if you notice, some of the tokens that we were looking at actually aren't things that have that same property. Yes, we were calling them tokens, but it's not like it is a discrete entity that only is generated once and then can trade. But things like a reputation score kind of fluctuates over time. Things like negawatts is a bit more strange to think about. And so this idea of value being active and is actually much more closely tied to anthropological understandings of value that foreground the social processes that are at the basis of economic exchange. And so with these new understandings of value come with it new ways of relating to infrastructure. And the transition from fossil fuels, as we thought of it, required new ways of coordinating humans and non-humans. So by designing and simulating peer-to-peer networks of resources, we imagine a more kind of collaborative energy future. And with its token system, we were hoping that FEEP provides an opportunity to codify and incentivize different types of social obligation, trust, and reputation, all kind of starting with what we see as like this core initial component of energy. So that went a lot faster than I think I expected it to. But you can find out more about our project at fee.is. And you can find me here on Twitter. And I guess we have, plenty of time. Yeah, time for questions.
Thank you so much. That was super cool. Yeah. You're in Berlin?
Yes.
Oh, cool. So are me and Danya. We'll talk more later. Anyway, so does anyone have any questions? All right. Yeah, we have lots of time for questions, so please ask questions.
Hi there. I might have completely missed this in your talk, but I see from your website that it's largely a sort of management system, so it's not really providing energy. So how is this really helping the promotion or creation of renewable energy networks?
Well, so it's great.
Is a management tool helpful in that sense?
Well, but it's for people simulating kind of the spawning up of different types of renewable energy, right? So your question's about what is the renewable angle to it, or what is the angle for like solar panels or wind turbines, or?
How does that support these renewable energy networks, and how does this really promote this type of networks?
Okay. Well,
both of these things I'm interested in.
So I think from our angle, the way we were thinking about it is by building sort of a simulation tool where communities could kind of get more comfortable and explore this. And they're not just simulating energy infrastructure that's already existing. They're specifically simulating the deployment of renewables for their local community. So the deployment of solar panels into their local community, the deployment of wind turbines into their local community, and seeing how that would kind of change their behavior, see how that would be able to compensate for the energy that they do need, if that makes sense. And then, you know, if you have a situation where there's people within the community doing those simulations, but also maybe experts who aren't part of that community, but who are interested and maybe more experienced in the idea of like designing microgrids, interacting with that as well, then together they can kind of come together with some plans, with network configurations that do make sense for a community, and then once that's sort of defined and set, like actually invest accordingly to create those networks. So the idea is that it's sort of simulation first, but simulation and then kind of like collaborative voting to enable a decision-making process for implementing eventually these networks. Does that kind of clarify?
Thanks, Cory. My question is around sort of the economics of your approach, because where does sort of capitalism land with this? Because it seems as if the underlying assumption is that a community has, you know, a shared amount of resources that they're collectively deciding on how to deploy from a renewable perspective. Mm-hmm. But is that the way that the world works versus an individual deploying their solar roof, for example, and generating energy that they can then resell to the point of local consumption? So I think, I understand that it's a collective decision-making, but is there collective capital to begin with in the real world? Yeah, no, it's a really good point. I think that this was actually something that when we were doing our research, we were seeing a lot, because if you look to research that exists around like microgrids and around like peer-to-peer energy markets, it really is kind of hyper
capitalist in a way, because ultimately it's bringing the market down to the individual consumer, where now the models and people are looking at like machine learning technology in here as well, where they're saying, okay, what is the actual optimal pricing strategy for an autonomous kind of individual actor within a larger context? I guess we sort of saw that as something that was happening, and while this model and the simulation as it exists right now kind of doesn't go into the economics at all currently, one of the things that was sort of at the core of this project that we wanted to have was the ability for people to experiment with different kinds of economic design. So this was hinted at a bit in the presentation, but it unfortunately didn't make it into the simulation demo that we were able to develop so far, where you would actually be able to have essentially similar to what the chatbot and map kind of did for the grid management software, there could be a layer of this that kind of exposes to the user a more intuitive way to interact with something like smart contracts, so people could design and have an understanding of what kind of economic logic they wanted their community to have. And through that, it could be one that lended more towards sort of market-driven approaches. It could be one that led more towards communal fund kind of techniques, but ultimately we sort of wanted that to be something that would be led kind of by a community and sort of by the people who would be using this kind of tool. But yeah, definitely something that was like part of a lot of our discussions.
Hi, thanks for the presentation. I have just a quick question about, I realize your presentation was on the simulation management sort of level of the project. Just curious, like how far ahead have you and your team thought about approaching an eventual logistical implementation phase? Like how would distributed energy work in a real world sense, like cabling, dealing with regulatory bodies that would probably try to interfere with a local, I'm just curious, like how far ahead have you thought about
Yeah,
this?
totally. So within the Russian context that we were operating in, like that was very clearly kind of a red flag if you were looking at stuff today, right? Like I think that within Russia at least, you are not able to sell, like in the EU, I believe it's possible to be generating energy either yourself individually or through like an energy cooperative and sell that back to the main grid. There actually isn't a way within Russia, as we understood it, to get energy from an individual producer or a consumer into the energy, like the wires just don't run that way. And so, and also the pricing within Russia, things are kind of mandated, the market prices for energy by the state. So we were definitely within that context kind of thinking more on a hypothetical lens, but this does kind of open up an interesting point about like where the project's at now and the ways that we're looking at continuing it. There's a few folks in different companies that are working either within the energy sector, like thinking about new energy, future renewable kind of developments, also stuff within this intersection of energy and blockchain that we're talking to based in Europe. But all of those discussions are more on us kind of like aligning strategy with them and trying to figure out where our work in this project can like be useful to them, and less about us getting into the nitty gritty of the cabling, for instance. So when in thinking, especially because my background is more in tech, the rest of the team's background also leaning kind of on this on the design and sort of urbanism side. Actually, luckily we have Iwen here today who is working on the project with me, coming from the Netherlands and China, and so. We didn't have an energy expert, for instance, right? But that's, there have been ways kind of since the conclusion of the project that we brought some people into sort of our fold who have more of that expertise. But yeah, kind of like things hitting on the ground is stuff that we're more interested in developing like with partners, basically, as it's not kind of part of our core competencies.
Hey, awesome project. This is really cool. I'm a huge fan of like simulation games like SimCity and City Skyline. I'm wondering if the data that you get from users that have built successful networks in this simulation, if you're planning on sharing that so that it can be incorporated in these types of games.
If this would feed back into those kinds of games?
Sure.
I don't think that we had thought about that. It's certainly an interesting idea. I mean, I think when we had thought about feedback loops and like the way that this data could propagate and like help improve simulations, it was quite contained to this sort of environment, right? But thinking about the interplay between other types of virtual environments, and then also that sort of reverse interplay between, like, if things were simulated in other virtual environments that would maybe be useful as data inputs for this, like, what would that look like? Definitely opens up a lot of interesting possibilities. Not one that we explored in too much depth, though. Yeah, thanks.
Hi, Cory. Two things. First, a comment and then a question. There are some communities, for example, in Mexico, I am in touch with one First Nation community that has decided that they don't want to depend on the nation electrical grid anymore. So they are deciding to, as a community, to create their own network. So this
Can I ask why they're doing that, or like what prompted that? To
autonomy. To autonomy, because they don't trust the central government, so they decided just to be apart and to grow, to be a peer, and then to be able to talk with them in a more level ground, let's say. So in that sense, this platform may definitely be very useful for them to understand what they are building. And then I wanted to ask you about if electrical grids are in general depend a lot on the power, on the model of consumption. So you usually design for the peaks and not for the valleys of consumption. And it would be very interesting. I would be very interested to know if you consider this on the design of your platform, and also regarding storage. With renewable, when you use renewable energy, you have also to store the energy for later use.
Yeah.
So I haven't seen them in your design storage facilities.
Yeah.
And maybe it would be interesting to consider that.
I can touch on the storage point first, and then I may ask you to repeat the first bit. On the storage side, so there was a point where we were actually thinking about having a separate kind of like node for batteries, right? But then all of these questions kind of came up, and this certainly could be something that we come back to at another point, was, okay, if you have these batteries, it's again this question of, so are the batteries communally owned? Are they owned by an individual person? And the way that we kind of were dealing with storage, which again, I don't think it was exposed too incredibly well in the UI, but basically every consumer, every peer has a sort of set allotment of storage capabilities that when they receive energy, that is kind of the energy that they would be trading with later. So any of the trading that happened, which if you continue through different day cycles, and let's say there's a day where there's not a lot of wind or sun, then trading that would happen between peers would all be because they have some like storage capability that's kind of like programmed in the actual like data model that we have for these peer nodes. But yeah, one of the things that we were thinking about earlier was having what was representing kind of storage and batteries as a separate node entirely, and thinking about the ownership models of that as well. But yeah, and the first.
So yeah, good to know. And regarding the consumption model, so the people, I mean, they consume basically all their energy in very specific ranges of time, and in a peak way. So how do you model? Have you considered that in your model also?
Yeah, this didn't make it into our model, but it's definitely it's something that would have to be accounted for, I think, if we were to like be implementing this in more of a real context. At the same time, I do think like when looking at things over like, you know, the time span that we were looking at was like day cycles, if you wanted to move even more macro, because if you want to be tying this stuff to the economic feasibility of these kind of models, you also want to be looking at what point does it become actually you're paying in less than you were when you were connected to the central grid. And to look at that, you need to be looking at the time scale of like months to maybe even years. And if that's the sort of time scale of your model and your simulation, then these sort of daily fluctuations of consumption kind of get washed over to a degree. So while it would be important to the actual networks, I don't know what value it would add when looking at that scale in the simulation. But maybe, I don't know, you seem like you have a thought on that. We can talk later maybe. Cool.
Okay, well, thank you so much.
Yep, thanks.